I think we've already met. Luca Olivari, MongoDB, Alan Gates, Hortonworks, Sean Owen Clodera, pardon, and Oscar Mendes Stratton. Adam Hattrell of DataStax speaking tomorrow. Adam, are you here today? You're not. Okay, let's go.
First question, or the things that we could talk, is about Hadoop 2.0, because it's one of the big evolutions that we have had in the last year, in a few months ago, well, 1 month or so, and you have been quite involved, especially Hortonworks, Cloudera, and so on. So what is new? What are the main improvements? I'm sure a lot of people here already know what is new, but sure you can tell us something very specific or where to use it. Specifically, what can you do new, or what can you do better with Hadoop 2.0?
All right. So at first I'd say Hadoop 2.0 is two things. It is a lot of changes to HDFS. So as we've already heard some today, and I'm sure you've heard in the past, the name node in HDFS didn't be fault tolerant. It didn't, if you lost the name node, the cluster was down for a while. So that's resolved, right? There are other improvements, ability to scale your file system past about 4,000 nodes, which was kind of a limit for the name node in 1.0. So that, on the HDFS side, that's one part. The big part that everybody talks about, and for good reason, it's very important, is the addition of Yarn to the processing side. So in Hadoop 1, there was one processing system, Mapreduce. We've been hearing about Mapreduce all day and why it's kind of old hat. Actually, Mapreduce is great for the things it does, but the points are valid that there's a whole set of things Mapreduce doesn't do. What Yarn does is takes and separates that execution system of Mapreduce from the resource scheduling of Hadoop, so that now with Yarn you can put other applications on your Hadoop cluster. With Yarn, Hadoop can run Spark, it can run Storm, it can run all these other systems and share those resources appropriately, so that you still have one cluster, you have one file system that's storing your data, and you have one resource scheduler that's controlling who gets what, so you're not fighting over, does Storm get this more than Hive to do my queries, those kinds of things. You can make all that work together. That's the huge improvement on the processing side for Hadoop 2.0.
Agree. So testing, yeah. So I tend to be more of a user of Hadoop than a Hadoop developer in my line of work, and that's definitely the most interesting piece for me. Having alternatives to Mapreduce as an execution framework, just because it's good for what it was originally intended for, which is basically logs processing, and it's not really a great fabric for machine learning, although it can get the job done. So it's been said a couple times here that Spark is sort of an alternative to Hadoop. Spark has its own execution environment called Mesos, but now can run on Yarn too. So these worlds are closer than they used to be thanks to things like Yarn. So it's the execution changes that are great for me.
Well, yeah, in fact, I think, Alan, you talked about this system last year. You talked about something to integrate or to share resources here in the Big Data Spain, and you put an example, something like similar, well, of course, not equal to the Java virtual machines or things like this. Could you explain something? Because I think last year it was like some introduction to what was going to be in the market, and now really is in the market.
Yeah, so I'm working from memory here, but kind of my assertion was that Hadoop is or will become the operating system of big data, right? And I think with Yarn that's now actually possible. So HDFS obviously gives you the file system. Yarn is now that execution layer that you can write, you can code against. So, I mean, we touched on all these different systems can run on Yarn. You yourself can now write your own execution system as well. If you have some new application that you want to do that doesn't fit in Mapreduce, doesn't fit in Spark or Storm or HBase or whatever else you're trying to use on your system, those APIs are open to you to write something. It's truly now an operating system where you can program against it.
Fine. The other question is, now there is a lot of buzz or noise about in-memory systems and so on. I think Yarn is the solution because, as you said, you can run Spark over Yarn or any other system. In fact, I think also Cloudera, you have included Spark like one of the innovators partners or something like this. I think it is the first one. What about in-memory systems and batch processing? When to use Hadoop? Imagine you have Hadoop with Yarn and you have Mapreduce. You can use it, and you can use also Spark or any other system. When to use one or other?
So Spark and those kind of things do depend pretty much on fitting in memory, right? That's how they get their speed. And they're really oriented around, as you said, iterative processing, where you want to go back over and over and over that data. That's how machine learning algorithms tend to work. And so they have to fit in memory. So if you can fit it in memory, you should, obviously. I mean, you might as well take advantage of that speed if you have it. Where you're going to go to batch is things where you're just doing a tremendous amount of work, and memory is just not going to be an option, right? If you want to build a map of the entire web, unless you have a lot of money, you're not going to fit that in memory, right? And you probably don't care. It's probably fine to build a map of the entire web once a week in a batch process that might take 12 hours, and then every hour you're maybe using Storm or something like that to update that map because you're doing that in real time. So often you find, and we've already seen this in several of the talks, this combination where you do the big heavy lifting in the background in batch, and then you supplement that in the real time with these in-memory systems.
Okay, thanks. One question that we have here in Spain and in Europe, I would say, is why the penetration of the big data technology is not as high as we expected. I mean, we think the technology has a lot of advantages, is disruptive, is mature. And so what is avoiding the companies to start using it in big projects and things like this? What do you think about? Because I think the USA is more advanced in this matter, but maybe, I don't know, in the UK, but in Europe and in Spain, it has maybe 1 year delay.
Yeah, I'll take this and then hand over to you. So it's probably true. In Europe, we tend to be probably 1 or 2 years ahead of the US in terms of adoption of new technology. However, considering MongoDB, I'm not so familiar with the Hadoop ecosystem, but we do have an extensive use of MongoDB already in Europe. Well, what you said is perfectly right. It's not for, as I said before in my talk, it's not for strictly big data projects. It's because of the agility of the technologies, because it can reduce by X% your development time, and because it takes less time to build new stuff. We've seen some big MongoDB clusters in Europe is growing, I would say, pretty fast. But yeah, the adoption is a bit late. In Spain, there are some companies that are doing interesting things with MongoDB. So I think seeing the various countries in Europe, we see something very unique here in Spain. There are some new companies that are experimenting with big data technologies and are well ahead of the curve. And it's happening also in the eastern part of Europe, because there are a lot of developers who are adopting big data technologies, and obviously UK or Germany or France, so the more mature market. But it's growing.
I get this question a lot in the UK. People say, is the UK behind the US market? And if so, how far? And the conventional wisdom seems to be that the UK itself is 6 to 12 months behind the US. I don't think that's really a long time. I'm not even sure that's statistically significant or true. I think you see, in terms of adoption from big companies, it's not all that different in the US versus Europe, for example. It seems like the US companies are maybe ahead, so to speak, just because you hear a lot of noise from the people maybe building the technologies, speculative startups trying to embrace them. But in terms of mainstream adoption, I really don't find it that different.
I guess one comment there too is when you hear stuff out of the US, you have to factor out Silicon Valley versus the rest of US. Because when I travel outside of the Silicon Valley, not only do I have to quit wearing my shorts and t-shirt and actually dress nicer, I also have to remember that those people aren't like day in and day out living and breathing Hadoop the way it happens in Silicon Valley. So I think you should be careful not to compare yourself against that versus what's happening in the rest of, you know, if you go to New York or Seattle or Texas or whatever.
Okay. What is this reason, because maybe it is something like back to the past or something, to make NoSQL databases with a SQL interface or like SQL? It is because it was very difficult for the developers or the guys in the companies to use it? Or what is the reason, this kind of fashion to go to the past?
So just to clarify, you mean why we are adding an SQL interface on top of the NoSQL technologies, right? Yeah, it's probably because relational databases have been here for 30 years. So if you study at the university, even today, you probably have some training around relational database. And the SQL interface, frankly, is not that bad. So you can very quickly elaborate your data. You have a rich interface. You can project your data, do group bys and things like that. It makes very, very easy to interact with your data. So the relational database model is not broken. On the other hand, the NoSQL solutions are trying to create new ways for accessing data. So if you add an SQL layer on top of the NoSQL technology, you have the best of both. But I'm not really sure if that's the way. In the case of MongoDB, for example, I'm not really sure if this solves the problem. So if you need an SQL interface, well, probably it's better to use a relational database in terms of MongoDB adoption. If you can cope with the JavaScript interface, if you need to build applications using the document model, then you don't need the SQL interface.
I've never really seen a serious counter proposal to SQL. I mean, for that kind of abstraction, for querying tabular data, core SQL is just fine. So maybe don't fix what's not broke.
Okay, fine. One other question was the use case. We have found that it is really difficult for the companies, even if they are convinced to go to big data, to find a real use case or a good use case or the business opportunity. What recommendation or what use case or what area do you think is better or suits better for this technology?
Should I start? Okay. So one of the challenges that we have with MongoDB is that it's a general purpose database. So we think that a broad amount of use cases that could be done with a relational database or even with other NoSQL solutions can be done with MongoDB. So what we found is pretty funny. We make the technology available for free as an open source solution, and we do have customers who are finding new use cases for us. So we try to capture these use cases, and we try then to bring them to the market. On the other hand, we have an internal focus as well, because it's a new technology. So the quickest way to adopt a new technology is to find a killer use case, the one that can give most advantages with the new technology. So we tend to go vertical in terms of the use cases, even if it's a general purpose solution.
What use cases or would I recommend someone look for? I mean, the simple answer is cost cutting. I mean, there's a lot of companies doing Hadoop-like work, not on Hadoop or on something expensive. That's an easy sell. It's always easy because it's fairly easy to quantify how much you're spending to do it one way, and if you can move that workload to Hadoop and save money, that's always an easy place to start, even if I don't think it's really the thing, the last step in the Hadoop journey and the thing we dream about.
Sorry, I have a question for you, actually. I know it's not standard, but yeah. What do you mean by cost cutting? So what are the use cases that they are moving to?
So I'm thinking of mostly ETL offload, so-called ETL offload. I'm extracting a bunch of data from logs and sensors or my ships and cars or something, loading it into a big expensive database. Some of that workload needs to belong in that big expensive database. Some of that data needs to live there. Maybe a lot of it doesn't. And if you can do that on a platform that, on commodity hardware, open source software, that can be a lot cheaper. And that's nice. And that's an easy argument to make. Let's get Hadoop in the door because it can save you money and it's the right tool for the right job here. And then maybe we can find additional use cases from there.
Yeah, I see a similarity. So we tend to work in a land and expand way. So we start to find a few projects where you can easily move to a NoSQL technology and then expand from there, because you need to be familiar with the technology to then use it for critical use cases.
Okay. Other point was, do you think this technology right now is complementing the previous technologies, but it will replace some of them, or what is the future? Is always a combination, or in some areas a combination, in other a replacement?
Well, so first of all, in software, I don't really believe in a future beyond 6 months. It's just impossible to predict, right? I mean, predicting the future is hard anyway, but in software, it's particularly hard. Everything we've seen today has been complementary, right? We don't see, I mean, when Hortonworks goes into accounts and we start supporting Hadoop, we don't see people turning off other systems. They are sometimes moving processing out of those systems, but that actually increases the value of that system for them, because now it's doing the work that that system's truly great at, right? Does that mean it'll never replace anything? I don't know, but I mean, that's hard to say. But technology dies slowly too. I mean, I was stunned at a couple of years ago at the Hadoop Summit. Sears, which is a major retailer in the United States, got up and gave a presentation on how they were moving from COBOL on mainframe to PIG on Hadoop. I didn't know anybody still ran COBOL anywhere, right?
But you would be surprised.
Yeah, I was surprised. I would be surprised again if I saw more of it. But the thing is, I mean, you know, I don't think anybody's written new COBOL in 30 years, right? But it's still out there running, you know, intentionally set out to write a system in COBOL in 30 years, but it's still out there running, right? And so old technology tends to have a long life.
Guys, we have some questions from the audience. I think they are pretty relevant. The first is from Esteban Chiner. I think, Esteban, you are speaking tomorrow, right? Or no, later? The question is, what are the main challenges in multi-tenancy, and how are new versions of Cloudera and Hortonworks going to tackle this problem?
You meaning running multiple processes on one node on a cluster?
Esteban, can you answer that one?
Lots of Hadoop work, or Hadoop plus other stuff? Mic coming up. So part of the answer is that we'll start while you're getting the. Part of the answer has to be things like Yarn, which is giving Hadoop the ability to schedule and balance resources of things within the Hadoop ecosystem, at least against each other.
Hello? Yeah. I guess the question was more on biggest institutions. You usually, or you tend not to have like separate clusters for different projects or different parts of the institution. So most of the cases they would share the clusters, the Hadoop clusters with. So my question was more, what are the challenges which I know some of them, like how you do that capacity planning, for example, when you're having separate projects running on the same cluster, and I've seen, for example, in Cloudera in the latest version 5, that they're adding something on multi-tenancy, but I'm not really sure what it is.
Gosh, what's in? You put me on the spot. I'm not actually sure what the multi-tenancy feature is. I would have said the two key problems in a big cluster in a big company. Second place is resource sharing, just making sure my jobs don't clobber other jobs, or in some reasonable way. But number one's really security, making sure the data in the file system, I can wall that off and make sure that I can also audit who's accessed what. That tends to be surprisingly important to government customers in a way that I don't care about, and I personally wouldn't have thought. So that's maybe the bigger concern, multi-tenancy.
So I would echo what you're saying there. Right? Security is definitely an issue. I mean, Hadoop does contain the right pieces now to enable you to wall your data off. It doesn't do so well with that, say, at the SQL layer, where it's harder to really control who does what. There's a lot of work going from both our companies going on in that front to address that. As far as capacity planning, I mean, Hadoop comes with a couple different schedulers. I'm more familiar with the capacity scheduler because it's what we use what we recommend at Hortonworks. But in those kinds of things, you can set up, this group gets X amount of the resources, and this other group gets Y amount. And what we tend to see people do is that is often based on how much those groups put into the cluster, right? If a company is going to bring in a cluster, say they're going to buy 100 nodes, and finance is going to pay for 20% of that, and marketing is going to pay for 40%, and I don't know, research is going to pay for 40%, then you tend to divvy it up that way, because that's at least a model we find that works. It works well for companies because they put their money where their programming is, right?
It's more or less exactly how it worked at Google, by the way. Just you'd put in money, not machines, and they pretended you'd given them machines.
Okay, this is a tweet by Vinko Salovic. Maybe it's a point for debate rather than a formal question. Hadoop will be the operating system of big data. It started to support different processing models, not only Mapreduce. And there's the next tweet, sorry. I meant to be this one. Sean Owen, how do you foresee a point-and-click tool for model to insight creation? I expect creating a generic tool to be hard.
So the question was again.
I repeat, Vinko, if you are here and you would like to substantiate that, please join us. Sean, how do you foresee a point-and-click tool for model to insight creation? I expect creating a generic tool to be hard.
Okay, so what's the future of point and click, data query, model building, visualization? I don't think Cloudera would ever build something like that, nowhere in the near future, just because we're not good at it. And there's plenty of people that have done this for much longer in the space, integrating with Hadoop to do that. So Tableau, Clickstream, what have you. These sort of BI tools can already query data in HDFS via Hive or Impala or whatever, and visualize it for you. Same goes for things like SAS. They have visual tools for click building models. Alteryx, another great company from the US, letting you click build workflows on Hadoop. Those problems are already solved, and I don't know if speaking for Cloudera, there would be any desire to get up into that space directly.
Okay, Ignacio Sales, I think you're speaking as well. Do you think that the speed at which the Hadoop ecosystem is evolving could actually have a negative impact on mainstream adoption? I think that's for the four of you.
Sorry.
Okay, I repeat the question, right? Now, do you think the speed at which the Hadoop environment is evolving at the speed, right?
Okay, I'll take a swing at it.
Sure.
So far, we don't see it having any negative impact, right? I mean, for one thing, it's not like the old versions vanish. I mean, we've all got SVN or Git or whatever. You can go back and get an older version if you're not comfortable with the bleeding edge. I mean, we certainly, we at Hortonworks release 3 to 4 times a year, but we don't see our customers adopting every one of those releases. They they come to one, they stay on it until they're comfortable with moving, which is often a year or more, and then they switch again. So it's not like you have to keep up at every point. Yeah, there's a lot of work going on. Some of that will take time to harden, and customers are going to need to decide where they're at on their risk tolerance there. But I don't think it's going to impede adoption. In many ways, it's speeding it because it's adding the features people need and want.
I'm being a bit provocative here. So one of the key differences that I see between Hadoop and MongoDB is the IP. So MongoDB and the source code is built by the company. So in a sense, we have more control over what's happening within the product, and this can be an advantage.
That's a good point. I would just say that I think the talk right before lunch highlighted what I think the problem is, and it's not that maybe Hadoop is changing and breaking. So that always happens in software. It's that there were names mentioned today that I'd never even heard of, projects and pieces of the ecosystem I'd never heard of. And if there's too much noise in the market, I mean, if it's confusing to me, it's probably confusing to several people in the audience. That may deter people from jumping on the next big thing or the next big thing just because they're not sure whether it's going to be not the next, it's going to be superseded in another year by another weirdly named project. That said, I can't say that I think that's been a net negative to date.
Okay, next two questions. One is for, sorry, yep.
Yeah, also I think that this speed about the evolution is not real. I mean, the 2.0 between Hadoop 1.0 and Hadoop 2.0, there have been several years. So the people has been working with Hadoop 1.0 very stable, very mature for a long years. So it is not really a problem. I think everything has been done with a lot of care and pretty well. And the next version, I don't know, but sure, Hadoop 3.0 will not be here next year, so don't worry.
Okay, we have a few questions more. One is for Sean, another for Luca, and a couple of questions more. So, Sean, future of Mahout. Directions, please.
Good question. Future of Mahout. This is a project I worked on from about 2009, although, gosh, it's a tough one. I think that in a way, so Mahout's basically machine learning algorithms on Hadoop. And it's easy to say that, but that's actually a massive remit, right? There's so many different algorithms you can implement, and as Hadoop gets additional processing models, there's so many different processing models you can implement. I think the scope is quite large, and there has unfortunately been, it's almost been a victim of too much scope. I mean, there's a lot of great code in there, but it's been hard for the project to keep up with all the evolution in the underlying technology. So it's actually unclear to me, to be honest. I think it's reached its level as a good chunk of code that's good for Hadoop 1, and I think we're going to see different solutions supersede it, different projects supersede it for Hadoop 2.
Great. Luca, can you please mention some of the Spanish MongoDB adoption cases? Names.
I'm not sure if they are public, so
Right.
the short answer is no. But I can maybe give an idea of the sectors. So we have big financial services institutions that are adopting MongoDB to do mainframe offloading, for example, or we have telco companies that are building innovative solutions around MongoDB. So the digital arm of some companies are using it. I'm not sure, to be transparent, which case study is public or not, but we do have adoption already. And the good thing is, well, there are two good things. One is Bill, who is responsible for sales. He's my colleague. He's sitting somewhere in the audience. So if you find a guy named Bill, ask him directly, because he knows much more about myself than myself. And the second thing is, again, going back to the fact that it's open source, if we check the number of leads coming into our systems, people who have downloaded MongoDB Enterprise or MongoDB Community or have attended conferences, the amount of interest in Spain is pretty big. And amongst these deals, you can find small companies or students who are just playing with it, and you can find huge organizations who are considering MongoDB. I spoke to someone during the lunch break, and he said that there is a pretty important project delivered by one of the biggest SIs in Spain that is using MongoDB.
Okay. Alejandro Valdominos, will ever big data technology perform well, at least as well as SQL, with small data? Okay. That's the question. Go ahead.
Yeah, I think it will. And I'll show some actual numbers tomorrow that will validate that assertion. But I definitely believe that, I mean, we're already seeing multiple systems achieving queries over hundreds of gigabytes in 2 to 5 seconds. Right? We're seeing that from Hive, we're seeing it from Impala, we're seeing it from Shark. So it will definitely get there. I mean, the thing is, Hadoop grew up around big and batch, and now it needs to learn to scale down, and it is going through that process.
And for MongoDB, it's the other way around. So it is already performing better than some SQL solutions. Because if you think about it, you're basically removing a layer. So with the SQL interface, you have to do the parsing, you have to check all the authorization and so on and so forth. So you waste a lot of CPU cycles in the SQL layer. So if you remove it and you access the data directly, which is what happened with MongoDB, you get actually better performance.
Yeah, I think we can say the same for more, well, non-SQL, like Mongo or Cassandra or whatever. Really, the through output is very, very big. In some cases, it is even bigger than in a SQL pure database. So I think it also affects the type of data that you have there. I mean, if it is really very structured and with very predefined schema, then a SQL database is the logical option, and we have said that. But anyway, I think for the through output in the NoSQL databases, they are really, really close. It depends on the data, the schema, how you have predefined your tables and so on for the SQL or the queries that you are going to do. And I think that for processing, as Alan said, really these low latency queries, projects like Impala or Stinger, that maybe you can tell us something more about them, are really getting very close. In fact, at the end, if you have some part of semi-structured data or not structured data, is the only option. So it depends on the data.
Okay, Mario Cordeiro asks, what about graph data? What is the current state of the art in big data?
I'll take it on the MongoDB side and then I'll over to them. There are specific solutions to handle graph data, like the usual graph databases like Neo4j or others. You can probably pretty easily model graph data within MongoDB, but again, there is a sweet spot for these technologies. So for what MongoDB is concerned, we have a guy working with a company that was working at Intergraph before, so he's helping us a lot to make it better for graph processing. So it can be done. It's probably not the sweet spot, at least not for Mongo.
Let's see, graph processing. I still tend to think there's only a small class of problems for which you need a graph algorithm. Things like PageRank come to mind, but that's a pretty specialized type of problem. That said, you can frame a lot of problems in terms of a graph framework. There's some great tools out there. There's Giraffe from Apache, but even better is probably GraphLab. But that said, there's a lot of the problems you can solve well with something like GraphLab are also solved well with other stuff, based on Spark or in some cases Mapreduce. So I still tend to think of graph processing as an interesting niche rather than something that's going to grow and become mainstream.
Okay, Vinko Salovic. You have your data in Hadoop and Mongo. You have no clue about statistics. Is there a repository of reusable models? What to do?
Statistics about what? About the data itself? Or?
No clue about statistics. By the way, I have to say, tomorrow there's a workshop about Hadoop on R, which might help in that direction. But anyway, that's
statistics in that sense.
Promotion.
Talking for MongoDB, you can connect some tools that are already built to handle statistical data, like R. You can connect it to MongoDB as well. I'm not sure if it was related to the statistics around the data that is within the database. So I'll answer that part as well. Yes, you can get statistics around what you have within the database. So you have metadata around your data within Mongo.
Yeah, I think the question was more about models, but Vinko, please feel free to correct us.
I store the data, but I don't know what to do with it. So is there some place to go look what to do?
So I've got data, now what? It sounds like you're interested in exploring the data in some sense. I mean, the first stops would be, hook up some kind of query engine so you can query the data. A lot of things that are called statistics. I mean, most useful statistics are pretty simple. The amount of counting and means and standard deviations, and you can do that in any of these SQL interfaces. You can also hook up just about any business intelligence tool you like to query those same SQL interfaces and then visualize the data. Some of them are free or have great trials too. You could try a bunch and just see what's giving you insights and pictures that are useful to you.
Yeah, I think one very easy solution for that is, okay, I have the data, now what? Then you have some tools, but some of the customers that are doing is integrating the BI tools like ClickView or Tableau or whatever with the big data system. Maybe it is only a no SQL database like in your case, but with any of these tools you can make a lot of insights and queries and questions and really have some value from that data, for sure, pretty easy. But other way, of course, and we have seen it quite a lot, is to make something ad hoc, to develop something, to make some very specific things. And of course, that is also pretty easy.
Yeah, and in the make or build debate, I think sometimes you need to make new stuff because the way in which the BI tools are presenting data are not necessarily the best ways to analyze big data. So some of the tools that you mentioned have specific charts, specific functionalities to analyze big data. So you need the right tool that can analyze the data, but is probably outside of the data processing layer. You need something on top of that.
I think tomorrow we have a visualization conference.
There are a couple of them, yeah.
Yeah, and there you will see some pretty good examples about how to visualize special data and to really get value from the data, because there are some times that if you don't invent something new to show the relations or the movement or in time and in geospatially for this data, you will not get all the value you can get. So please, if you are interested, go to some of the two conferences we have tomorrow.
Also, I'm filtering out some questions that are more relevant maybe for the roundtable tomorrow about business. So one last question maybe, because we are running out of time, by Jesus Renero. When, if any, is KVM and cloud suitable for running Hadoop-based big data platforms for internal use?
So when is it okay to run on a virtualized instance? Is that the question?
Jesus, you want to, yeah?
I think it's fine. I mean, the conventional wisdom is it's always best to run on bare metal, but the performance penalty in a virtualized environment is not huge. Certainly if the use case is testing or experimentation, absolutely. I mean, we've got customers that use EC2, and it's fine. Yeah, same. No reason not to. No reason not to.
Yeah. Okay.
One last question. A lot of people or companies are using big data with the cloud systems, but sometimes we have a kind of problem with the virtualization and the latencies there, and this is something a bit tricky because it is like, okay, shift to cloud, and also join with big data and so on, but sometimes it's not the best combination. Then what recommendations, when to use it, when not to use it?
I guess I should say that even with bare metal, you could build a cluster that had a load of hardware and still was terrible. I mean, if you had, a one disk per machine and a load of CPU and memory, you're probably going to bottleneck quite quickly on that disk. Or if you set up the OS in a bizarre way, that it won't perform well. And virtualization just gives you another set of settings to get wrong, I suppose. So I guess maybe the lesson is that it does require tuning and understanding of what virtualization means and what the workload Hadoop's going to put on those machines. But in principle, when set up right, it can be fine.
And last one, what about real-time data streaming combination with batch or with interactive and so on, or to integrate the Storm or other technologies? There is some work to replace the real-time data streaming analyzing with Hadoop or with Impala or with, what is your idea? Are you working on something like this or integrating technologies like Storm?
So at the moment the focus is really on integrating things like Storm, but it seems to me we see a pretty common model here, right? We saw this in Hadoop 1. First it was Mapreduce, that was all there was. It was Java, which works for about 1 to 5% of the people that actually want access to the data. Not long after that, Pig and Hive come along. Now, and also just some higher level Java interfaces like cascading, which is still in Java, but you don't have to think about writing actual Mapreduce code. I suspect we'll see the same thing in the real-time world, right? Right now it's Java or Scala or Clojure if you're really brave. But you know, that doesn't work for everybody. A lot of people either don't know Java or don't want to program at that level. And I assume over time we'll see, you know, new languages or at least new methodologies come about to open that up to more and more users.
Okay, very good. Thank you very much, Luca, Alan, Sean, and Oscar. I have some announcement to make. Good news. We have a short drinks break now, but at 6 o'clock downstairs, there's an open bar for everybody holding the card, the Big Data Spine card. So we have 1 hour and a half free beer, wine, or whatever you want to have. And that is sponsored by Paradigma, the organizers of the conference, and by Stratio, one of the platinum sponsors. So thank you very much, and enjoy.